I am a mechanical engineer by degree, but really for the last maybe 5 years, I've been focusing on energy and sustainability for our clients. We've had a lot of really great success stories coming out of this charrette exercise, and so we wanted to share how you all can conduct a similar charrette when you're kicking off projects, and so that you can have some of those similar success stories at the end. You can see the agenda on the screen. I was going to quickly go to an how-to document that we're going to be providing to the audience. And then the bulk of this exercise is really going to be a pseudo example. What I mean by that is I want you all to be participants as if this was a charrette. You are the client, and maybe I'm facilitating, and so to get some of that interaction. So as part of that, if you do want to log into that menti.com and use that code that you're seeing down there, 45745295, you can be an active participant. To round out, I'll give a brief example of a charrette that we conducted for a client and the success story that came out of that. And then time pending, I think anywhere between, if you add all this time up, it's about 55 minutes. So hopefully we have anywhere between 10 and 15 for some Q&A. So with that, and I'll take maybe a break after step 2 just to see if there's any mid Q&A. So as far as how-to, so this document is, I'm intentionally high level, bringing it up just so that you can see all of the slides. This is the how-to document that is an internal document for your reference. So this kind of talks about maybe more of the minutia of what I'm going to describe in coming up. But like I said earlier, I think the best experience is to be part of that charrette, and so that's what I'm going to move into next. So, but what you're seeing up here is that how-to document. Mary Tobin, who was with our San Diego office and has now moved overseas, so she is over going to be restarting next September in the Stuttgart office. She put this together, and so this will be provided to you at the end of this recording. So to hop back over to the actual pseudo example, and again, if you want to jump onto that menti.com because you're going to have a question coming up here shortly, this is really what a typical energy and sustainability charrette agenda would look like. So you can see there, the purpose of the charrette is really to get all the major stakeholders and start mapping out some of those energy and sustainability solutions. I would caution you, they are changing rapidly. So every, even the client that you might have worked with a year ago and you might say, yeah, I know what your plans are. Those plans and goals and commitments are ever evolving. So be mindful of that. But you can see the attendees, it's all the major stakeholders. So all the discipline leads, all the subject matter experts from the client side. Make sure to get your EH&S involved. And you're going to see there in that agenda, I typically like to reserve about 90 minutes. I find 60 is just a little too short, and anything more than 90 starts to seem a little too long for people's attention span. So 90 minutes seems to be a nice sweet spot. And for this exercise, we're going to be condensing that into 30. So I am going to move quick, but obviously I'm going to skip over introductions and skip over, and we're going to consolidate some of the brainstorming exercises. At the bottom, what you're seeing is some of the deliverables, so conditions of satisfaction, KPIs, goals, and I'm going to talk more detail about what those mean, but those are some of the tangible items that can come out of this charrette exercise. So with that, hopefully people have been able to log into the menti.com, and wow, it looks like people are quite ahead of me. So this is fantastic. I like to do this exercise really for 2 reasons. One is that it is thought-provoking, right? Like I think we say the word sustainability often, and then when you're actually forced to write that down of what it means to you, you start to think, it becomes a little bit more meaningful. The other thing is just simply an icebreaker, right? So when you are in a client setting, that you can get client participation in active voices so that people feel in a comfortable spot. So with having as many people on the call, we're certainly going to limit that amount of free talk, but when you're with a client, you can start to open it up to the audience and start asking about if there's anything that they see that it's surprising or if it's matching. But you're seeing a lot of things on the screen: green, efficiency, environmental, responsibility. There's a lot of smart design. I would say, the overall arching thing is a lot of green, right? So I'm going to roll in. That'll continue to populate on the side. So if you didn't get all your questions in or your words in, continue to add to that. But as far as a sustainability overview, we generally look at it from these three major principles or these three major pillars: environmental, social, and governance, also known as people, planet, profit, also known as the triple bottom line. And the thought here is that you cannot have just one or just two, but to be a sustainable company long term, you really need to focus on all three. So while we generally immediately gravitate to environmental, and quite honestly, I'm going to be focusing mostly on that, it's equally important to focus on that governance side, making sure that you are going to stay in business, and make sure that social sustainability, that people side, that's your most valuable asset. So take care of your people, and the people will take care of the business. So three important aspects of a sustainable company. One of the other kind of macro level things that we like to look at is this United Nations Sustainable Development Goals, also referred to as the SDGs. So a lot of clients are aligning some of their priorities around these different 17 initiatives. And so we polled 20 of our major clients, and that's what you're seeing on the right hand side. And you'll see a similar trend around the ones that are most common. Good health and well-being, aka people. You're seeing responsible consumption and production. It's kind of like being lean and making sure that your profits are maintained. And then climate action, that's that environmental. So it's kind of not maybe surprising that the three most popular items that clients are aligning with the SDGs also align with that ESG, that environmental social governance. So before we move too far into some of the details, I do like to make sure that we're all level set with what is carbon. So, because I think, again, that term is used often, but I'm not sure if we're fully always on the same page with what it means. So carbon dioxide equivalent is really, and that's 80% of what makes up greenhouse gases or global warming. The other 20% being some of those methanes, that nitrous oxides and fluorinated gases. And really that's what creates that outer layer and traps heat in our atmosphere. So from the EPA, they've also identified scopes 1, 2, and 3 emissions. And I usually like to start backwards from scope 3 and go back, because scope 3 is, those things are really kind of out of our control. They are because of our business. So commuting to work or commuting for travel, those are things that exist because of our business, but I can't control whether you drive a V8 pickup truck or whether you drive a Prius. And so those are things that you might have an influence over, but not direct control. Scope 2 is that those emissions that you're consuming on your site, but are occurring off-site. So this is kind of that conversation around, just because you electrify a facility or electrify a car, it doesn't necessarily make it clean, because you need to know where that generation source is coming from. If it's coming from a coal plant, that's not a clean technology. If it's coming from renewable, that is good. And really a lot of our clients are focusing on this scope 1, because that is what they do have direct control over on site. And that's largely that natural gas component and some of those fugitive emissions, which largely is refrigerants. So now that we talked about what carbon is, now we can talk, well, why do we really care about carbon? So this is from the AIA 2030. There's a commitment out there to design all facilities to be zero carbon by the year 2030 by the AIA. And they've produced this center graphic that you're seeing, the corresponding CO2 in the atmosphere relative to the global temperature for the last 400,000 years. So this is taken out of ice core samples. And you can see that small sliver on the right-hand side, which represents the last 100 or 200 years, has a dramatic increase in CO2 in the atmosphere. And so, of course, the worry is that if 400,000 years of trend data repeats itself, that the global temperature will also rise. And so that inherently went to the Paris Agreement, which we're trying to limit our rise to 1.5 degrees, no more than 2 degrees. And we're currently at 1.1. So we're certainly trending closer and closer to that 1.5, which is not a good thing. So that's a little bit of sustainability overview. And I'll check if there are questions, you can feel free to type them in the chat, and I'll see if I can take a couple breaks between these different dividers and answer anything that comes up. But as far as industry trends go, this is kind of what we like to talk with our clients about next. And some clients are more up to speed, and a lot of clients they're startups. They've never heard any of this conversation. But one of the better ways of curbing carbon is by pricing it accordingly, carbon tax. So what you're seeing here is globally of all the countries that have started to put a price or a tax on carbon emissions. What you're seeing is the United States and notably maybe even Australia are not on that list. And so those are some of the more developed countries that have not enacted carbon pricing. But specifically to the US, you are seeing a couple dots that are state specific, where some of the states have taken it into their own hands to apply some of that carbon tax. So my own home state, California, yes, we do have a carbon tax, and I actually got a California climate credit on my bill last month because they basically tax the heavy emitters and then redistribute that to the ratepayers. So the states are also taking it another step and saying, well, we're going to create a renewable portfolio standard. So I'll also call it an RPS or an RPE, renewable portfolio energy. And it's different commitments, whether it's a codified or a goal of how much renewable they're going to have on their grid by a certain date. So what you're seeing there is California has codified 60% of renewable energy is going to be online by 2030. Here in 2022, we're at about 30%, so about halfway there, and 100% by 2045. So that is allowing, so in theory, if you electrify a facility in 2045, you are going to be zero carbon because you're going to be consuming 100% renewable electricity. But there are some strategies to actually accelerate that even more quickly, which we'll talk about shortly. So where's all this power coming from? If you jump onto the EIA, I think it's a really great website, Energy Information Administration. You can look at your own home state and you can see where all this power is being generated. So California does have a good mix of, you're seeing a lot of those yellows, which is solar. So a lot of in the inland area. You're seeing a lot of hydro and blue up in the northern mountains. You're seeing a lot of wind with the gray dots. And then you're seeing some biomass with the green leaves. So a good little mixture of renewables that makes up that zero carbon energy sources. So when I mentioned that you don't have to necessarily wait till 2045 to have clean electricity, the reason being is that a lot of the investor-owned utilities, the IOUs, are getting out of the generation business. Renewables are now at price parity with fossil fuels, and as those plants continue to age and it becomes more expensive to maintain, the IOUs have found that it's cheaper to leave that to private industry. So the utility will still be your billing mechanism and your wires and transmission. They're just going to leave the generation up to private sector, which that now gives the customer a choice of where do they want to procure that electricity from. And so that's what ultimately came about these CCAs. And we're going to show an example when we get to that part of this conversation. So this is a little bit of maybe the carrot and the stick. So that was the carrot, is like, hey, there's green electricity available to you, and you can actually maybe even save a little bit money. Here's a little bit of the stick of, well, some jurisdictions are saying, no, we're just going to outlaw, ban, or restrict fossil fuels altogether. And so they call them reach codes. So beyond what maybe the state code has enacted. So here in the state of California, we're up to about 56 AHJs that have banned or restricted the use of natural gas. There's a few on the East Coast, Massachusetts and Maryland, that have started to enact some of their own bans. And then including 2 here in San Diego. So I am part of the San Diego Building Electrification Coalition, so I felt like I had to give a little plug here. But San Diego County did get its first 2 cities, communities that have put in an all-electric ordinance. And so we're starting to see that trend become more and more popular. Not everything is rosy, though. As different weather-related events start to multiply and intensify, and you put more and more responsibility in that electric grid that's aging, it makes it more fragile. And so we need to recognize that that is one of the challenges as we move into the the next energy transition. So making our facilities more resilient, more robust is probably the most important thing that I think that we could do as we move into the next series of design. So I'm going to stop there just to see if there are any other questions before I go into sustainability goals. Again, if you logged in recently, you can go ahead and use the chat feature and drop in any questions that you might have. And I'll just give that just a moment.
Can we speak instead of type?
Sure.
Okay. So my question is, when we talk about the distribution, which it's my biggest kind of concern, and what I have been noticing in United States, that especially in a older distribution system, all electricity or electrical wires are above ground. And if you go to Europe, the majority, except a very high voltage, are below ground. Is that something that the industry is considering, of as it's a need for upgrade of the infrastructure?
You're touching on a sensitive topic for myself. My dad was a San Diego Gas and Electric employee for 30 years. One of the things that we're experiencing out here in the West is some of fire season, and and I'll make the connection here shortly, is when you have above ground wires and you have an object, maybe a tarp or maybe tumbleweed, whatever that is, that gets blown up onto the wires, and it connects across both, and it sparks and it flashes, and it's in the dry season, you can start a fire very easily, and that we've seen that happen every single year. And those fires have caused damage to life and property. And at the end of the day, they say, who's responsible for that? And ultimately, the utility is, or at least has been found guilty of it. At the same time, as the utility says, we're going to underground a lot of these wires to make it more safe, that is a very expensive cost, and that cost gets put onto the ratepayers, which doesn't make them happy. So it's kind of it's a predicament that the utility, if you really put yourself in their shoes of what is the right solution, leave them above and take the chance of a fire happening, put them below and put that cost onto the ratepayer. So we are starting to see that, especially in those fire prone areas. I'm not as familiar elsewhere in the country.
Okay, thank you.
There was a question in here about how would you inquire about LEED green gold certification on a project. So certainly I'm going to talk a little bit about that coming up. So if I don't answer your question, please reach back out and make sure that that I do get that fully answered. So we're going to talk a little bit about some of the sustainability goals. So again, if this was a project, and let's just, for instance, we were working with Amgen or Gilead or AstraZeneca, this slide would be dedicated around those, and we would do our own research. But please, once you've done your research, then just ask your client. Make sure that these goals are ever changing. So make sure to ask that. A couple things I just wanted to highlight is that there's some common themes around a lot of our clients, certainly around carbon. So you have Amgen that is looking to be zero carbon in 2027. That is very near. Gilead by 2030, AZ by 25, Roche, Genentech by 2050. What you're also seeing is water. So water consumption, again, Amgen 40% reduction. Gilead, water neutrality for water stressed regions. If California is not water stressed, I'm not sure what is. So according to their standard, we need to be water neutral. I'm not even sure how to do that. So that is, going to be the next big challenge that we're going to see. Roche has a 15% reduction. And then again, you've got a lot of clients that are also focusing on waste. So really carbon, water, waste are those common reduction measures. And how to do this it's not easy. It's not trivial. So that's where we need all of your help and all your good ideas to come about. That last one was with regard to refrigerants. So to move on to some of the building rating and certification. So there was a question on there about LEED and green globes, which you're seeing here on the screen, but there are 600 different green building certifications. Which one to apply, I guess, depends really on what your client's goals are. So if they're focusing on kind of holistic building design, LEED might be the solution for you. If you're focusing more on the health and wellness of the people, you might want to consider WELL or FitWell. So it kind of, it does depend. Both WELL and LEED are both ran by the US GBC. And so they have very similar silver, gold, platinum type of approaches. One of the other ones that we're seeing a little bit more of an uptick is My Green Lab, but I will say that's more of an operations objective and less of a facility design. So you might want to share some of the good practices at My Green Labs with your client, but it's not going to necessarily impact our facility the way that we approach our facility. So this is going to bring us to the next Menti. So if you wouldn't mind jumping on there, and I'll try to advance it just so on my other screen. But really, we try to look at these different categories for, this becomes our decision-making lens, because oftentimes there is a trade-off when we are looking at carbon, resiliency, water. If you want to be more resilient, usually it's going to cost you a little bit more. If you want to save energy, maybe it's at the expense of consuming more water. So there's often trade-offs, and so what we'd like to do is start to level set these different categories so that when we do have a conversation about what decision do we want to make, we can refer back to the decision-making lens and say, well, according to you, CapEx was least important or most important, so that we can try to guide the client in that right direction. So I'm going to advance on to this slide. I was trying to keep that hidden just for a moment, just to not influence people, but looks like we've already got quite a few respondees. And you can see, according to you all, CRBers, you can see the importance on water and carbon. It looks like we keep on trading spots on that first and second. Not surprisingly, health and wellness and resiliency is the top of there as well. It's not uncommon that building certifications rounds out at the bottom. I would say that building certifications, it's not that it's unimportant, it's that it's a tool used to achieve those higher priority items. And so that's often the approach that we do. While carbon, water, and health and wellness might be your top criteria, the building cert can help you get there kind of from a more objective standpoint. So this is really great feedback. Looks like, yeah, carbon and water rounded out the top there. So as we move into some of the solutions, so keep your Menti open and ready. Let me make sure that it did get updated. I think that's cooperating. So this is the next exercise that we like to do, of trying to hear back from the client of what innovations do you want us to consider? What would you like us to evaluate? And why I like to do this, so CRB, we do have a 150 to 180 list item of different conservation measures that we can go through that list. And you're going to find more and more clients. Pfizer has an EED, an energy efficiency design checklist, and some of the other players, CSL has a checklist and Takeda has a checklist. So, but for those clients that don't have a checklist, CRB does have one. But why I still like to ask the clients of what they want to see is just it gives a sense of ownership. There's always a chance that they might have a new idea, which is great. I mean, that's one goal. But the other is, yeah, that sense of ownership. So whether it's a design lead or a discipline lead or a client member, they can say, hey, I put green roof on there and we ended up enacting green roof. And so like that can be, your ownership. So you can see the items on the screen. Engineered timber. We weren't really going to talk much about embodied carbon, but that's certainly a whole conversation in itself. So I'm excited that there's some people on the call that are already hearing some of those terms and why some of those things are more important. Carbon neutral, etc. So this is an example of recent charrette where this is the 17 items that were discussed during that charrette for this for a specific project. And ultimately, the client said, hey, I'd like you to look at these, whatever it is, 4 or 5 items in a little further detail. So a lot of times when we get reached out to saying, hey, can you conduct a charrette? How much does it cost or how much time? The charrette itself is pretty quick. It's 90 minutes, a couple hours on the front end, a couple hours on the back end. It's not a big task. But these next level evaluations is where things can, start to, snowball, not necessarily in a negative way. We just need to be mindful towards it. So sometimes we will say, we'll evaluate up to X items, into that next level of detail. But you can see here, solar storage, 100% electrification, ambient Wi-Fi, air change rate reduction. So those were the things that they wanted us to evaluate for this. As far as, and to round out this this kind of this template, is what are those deliverables? Well, there's the charrette, which we're doing right here, right now, as a pseudo. So all those inputs that you've provided, that would roll into an A3 document or the basis of design, and that would be, we would memorialize that as part of our charter effort. So when we say that we're going to establish conditions of satisfaction and KPIs and different goals, that's exactly what this whole exercise is. Let me make sure that everyone is aware. A condition of satisfaction is a project requirement. That's a pass-fail. If you don't meet it, you fail. You meet it, you pass. Whereas a goal is exactly that. So make sure that when you're talking with your clients, that you are differentiating. It's okay to have maybe 1 or 2 conditions of satisfaction and then several goals. And then really KPIs, key performance indicators, technically could be either. I mentioned the conservation measures. So in that example previously, we had 4 or 5 that we green lit. So, we would do that next level of return on investment, seeing if there are any financing strategies. Maybe there's some government incentives, whether federal or state level, that we can do to help bring that ROI down. And then the last one is the building certification review. So oftentimes we might be, quote, designed to LEED standard, or maybe we are going after LEED Gold. And so based on some of the conversations that we're having, we can start to say, hey, where on the scorecard do we think that we can get these credits and get these points and corresponding certification level? The last slide I have before I move into the CRB example is this I2SL. I did get the opportunity to present a similar presentation to I2SL, which is the International Institute of Sustainable Laboratories. They do cover bio and pharma, so it's not, quote, just labs. Really great documentation on there. I would say they're maybe one of the more technical organizations that I've been involved with, which I really appreciate. So if you're interested in any of the things that you're seeing on the screen, or just want to go and explore, jump onto that I2SL website and take a look. So I'm going to pause there. We're half past the hour, and I do see there's a couple of new comments. How do you generate steam in an all-electric scenario when some states are telling people not to plug in their electric cars during certain times of the day? How practical is battery storage for steam generation or chillers? Well, we are going to talk about that in the example that we did. Batteries are finite. How do you generate steam in an all-electric scenario? So steam is the enemy. I want to make that very clear. Reduce steam, reduce steam, reduce steam. I think we get caught in this snowball effect where we need steam for a couple of sterilization features. Maybe your WFI, maybe your glass wash, your autoclave. And once you have a small steam generator, there's a benefit to making a large steam generator and then having a heat exchanger for hot water. We need to get away from that now that we're moving into this decarbonization world. So always use the lowest grade heat necessary for that product or for that system. So for hot water, do not use steam. Do not use electric resistance if at all possible, and only reserve it. And then even WFI, we're going to, can we go with ambient? There's only 2 pharmacopoeias out there that are not yet allowing that. So maybe that's something that we can consider in the future. Do you apply any project with steam generation with solar energy? I've not personally, but I think that there's potential there. Certainly on the utility scale, that does exist with concentrated solar panels where you're using parabolic shape reflectors to concentrate that energy and produce steam to drive a turbine. But I have not seen that at the commercial scale. And then how often do natural refrigerants come into play with projects to reduce greenhouse gas? That's a good one, because I think a lot of clients are claiming zero carbon, but they don't always know what that means. And so when we talk about refrigerants that have a global warming potential and inherently they do leak, that is part of their carbon footprint. But we don't necessarily have all the technology available to us today to go fully natural, or it comes with some other challenges. So that one's kind of still a work in progress. And there was a question, or there was a hand raised. If you want to go ahead and unmute yourself, you can go ahead and ask that question.
Hey, Jeff. Just a quick question. I know in my previous days when I did a little bit of HVAC, I was just wondering if our clients consider replacing certain refrigerants, like particularly R22. I know at one time it was being phased out to 410A, and I just wasn't sure if they, if our clients are aware of it and if they do know that there is payback programs that are offered.
Yeah, I mean, so R22 certainly, that's been on the chopping block for a bit of time. And so that, I think most clients are aware of that and they're ahead of the curve. 410 and 134 though, those are probably your most common refrigerants, and even those are getting scrutinized. In Europe, they've now dropped the GWP on average to about 600, whereas 410 and 134 are up in the 1500s, and California is moving towards a less than 750 mandate, so also would preclude 410 and 134. So we're seeing a lot of manufacturers kind of scramble with, keeping up with either the EU or California specific. And so that is a active conversation that we are going to be navigating over the next couple of years ahead.
Thank you.
Could it be beneficial as a lab designer to obtain green lab certification? Yes, I am. I'm a green lab ambassador. I think if nothing else, I think it's a good educational piece. I learned I will never use that in practice, but just educating myself with how our clients operate, I think there's value there. It was not a lot of effort, so yeah, I encourage you to go on there, become an ambassador, and I think if there's any discipline in CRB that would benefit most, it would be that lab planner. So certainly encourage you to check that out. So we're at 34 past the hour. So I'm going to roll in for maybe a 10-15 minute CRB example of how we were able to perform a charrette and what the story that came out of that. So again, continue to keep your questions coming through the chat window, and I'll jump into this CRB example. This is for Allogene Therapeutics. They are an ATMP, an advanced therapy medicinal product. Allogene by name, it's allogenic cell therapy. So allo being using donor cells versus autologous is like your autoimmune system using your own cells. That's about as far as the process side of things that I'll go into. But this client, they were a startup. There was a lot of former Amgen and Boehringer Ingelheim executives, both coming from pretty progressive companies that had some good goals. Amgen probably one of the most stringent out there. So they knew they wanted to be green, they wanted to be sustainable. They just didn't really know what that meant. So I got a call from our business development person saying, "Hey, can you?" At the time, I don't even know if we called it a charrette, but can you come and talk to this client about the way the industry trends are heading? So he said, sure. And at the time, if you remember, I mentioned earlier that California currently has 56 jurisdictions that have banned or restricted natural gas. At the time of this charrette, there was 0. Berkeley was first in 2018, and this is when we did the charrette in 2018. So at the time there was 0, but we were seeing a lot of that legislation. We were talking about how some of the industry trends, we were talking about California's drought and just a lot of those current events. What we ultimately came up with from the client was carbon, water, and resiliency. They identified as being their most important, highest priority items that they wanted us to focus. So we, started bringing that back in-house and started socializing it of how are we going to get to a low carbon or a zero carbon approach. And so this was created with several CRBers. We had a task force put together, and we really came up with this 4-step process. And I think this has been really powerful because I like to think that it's really simple. Step 1, reduce before you produce, right? That's nothing new. That's everything that we've been doing for a long time. And that's applying those energy efficiency measures. Step 2 is that thing that's a little bit new, right? And a little bit makes people a little uncomfortable is removing that fossil fuel that we've grown to know is just a standard practice, and largely electrify that facility. And once we put all of that responsibility in the electrical basket, how can we make it more resilient? So how can we produce our own power on site, and how can we store that power on site? So I think that was one of the questions that came up in the chat window. And then the last step is relying on the grid as your last resort. So consume 100% renewable grid, which we talked about through that, community choice aggregates and some of those renewable portfolio standards. So I'm going to skip step 1 and just jump right into step 2, this electrification. And when you hear that term, I think people a lot of times they think of solar and storage and electric vehicles and just climate goals. But the reality that the elephant in the room is heating. So I think there's a couple people already touched on it in the chat window of how do you do steam? How do you do autoclaves and sterilization and just reheat? I mean, that's where when you convert those natural gas BTUs, it's not to kW, it's to MW, it's megawatts worth of energy. So it's something that we need to be very mindful of. How do we address heating and how do we make it least impactful possible? So similar to that 4-step zero carbon, I did put together this 4-step zero carbon heating approach. So very similar to step 1, reduce before you produce. So why do we need to heat up to 75 degrees in the winter when we could maybe heat up to 70 degrees? So that's just like simple reduction measures. From a recovery, a lot of things that didn't pencil out previously are starting to pencil out because we're putting a higher price on carbon. So, remember, energy is not carbon. So sometimes it might be a little bit more energy intensive, but if it's at the carbon reduction, there might be a net benefit. So when you're thinking about air side, water side recovery, reevaluate what you may have done 5 or 10 years ago because it may pencil out today that didn't pencil out before. Step 3, just keeping with the, is the 4 R's or the 6 R's, but reverse cycle heat pumps. So heat pumps are much more efficient, which you're going to see a graphic on the next slide. And then responsible refrigerants. So what does that mean? Well, back, Lewis, to your question, it kind of means a little bit to different people. Is it quite natural? Maybe. I mean, that's ideal, but there's some challenges with ammonia toxicity and hydrocarbon flammability and CO2 pressures. So there's not really a perfect solution on the natural fronts, but we are seeing some very low GWP alternatives, some of those HFOs that have come out recently. And then again, the last step is to use electric resistance. So only use electric resistance for the things that you absolutely have to as that step 4. So for this client, we evaluated a few different mechanical approaches. We ended up going with this air-cooled water heat pump, heat recovery heat pump. That's a mouthful. But what you're seeing is it looks like really a modular chiller. It looks like a 60-ton modular chiller, which effectively it is. But you're seeing 4 pipes, a chilled water, 2 chilled, and 2 hot. So what's great about that is it's very efficient. And I think a lot of people will say, well, natural gas is so cheap, so why would I not want to use natural gas? And I'm going to say, well, it is cheap. It's maybe on the magnitude of 3-4 times cheaper than electricity, but it's also not that efficient. Natural gas boiler might be 90% efficient, so it's got a COP of 0.9. It's output over input, right? When you go electric resistance, you get 100% efficient. All of that electricity goes into a wire that then heats the medium that's heating. So it's 100% efficient. You can't do better than that, which is true when you're talking about thermal conversion, but untrue when you're talking about thermal movement. So when we want to convert electricity, it's 100%. But when we want to move heat via electricity, no different than your refrigerator, than your air conditioner in your car, or your chiller in your central plant, we can get about COPs of about 3 or 300% finger quote effective. So and a heat pump is no different than a chiller. It's just reverse cycle. I think oftentimes we just think about the rooftop package heat pump, but really it's a chiller run in reverse. And then for a lot of our facilities that are overcooling for dehumidification and then reheating, and so we have that simultaneous load year round, that's where this particular approach can really start to shine. So this particular product, it does have 3 coils, a hot coil, a cold coil, and an air coil. So when it's in heating dominant, it's going to grab the heat out of there. When it's in cooling dominant, it's going to reject the heat to the air. And when you are in that perfect state of heating and cooling, you can just transfer water to water and get those 8.5 COP efficiencies. So moving on to step 3, now that we fully electrified the central plant, now we can blanket the entire building in solar photovoltaic. So on this job, we were able to install upwards of 1 megawatt worth of energy. It was maybe in the 900 kW range. And we had a lot of challenges with roof loading. We don't have snow loads out here in California, so we had this was built as a distribution warehouse, and then we came in to do some GMP manufacturing. So we had a lot of challenges, but we ultimately were able to make it work. And ultimately, this is what the building looks like. So all the air handlers, there's 17 air handlers, all on equipment platform indoors. Exhaust fans are indoors with a stack sticking out. All you're seeing is some gravity ventilators, some condensing units. And the rest of the entire rooftop, as much as we could possibly filled, is with solar photovoltaic. That's going to offset about 50% of the energy consumption. And then, as most people know, utilities are smart enough to know that everyone's putting solar on at the same time, and when the sun comes up and the sun goes down. So they're starting to price things accordingly and starting to shift that time of use pricing to be more expensive in the evening. So what we also did at the same time is went ahead and started suggested a energy storage system, battery energy storage system. So we did end up going with a 1 megawatt hour battery energy storage. So we had 1 megawatt of solar, 1 megawatt hour of battery. So this is the Tesla Megapack. It's a pretty small footprint, 6 foot deep, 20 foot wide. We used to have Conex containers that were about twice the size and half the capacity, maybe just 5-10 years ago. So the density of these energy storage systems has accelerated quickly. And then really that last step, if you remember step 1's 2, 3, and 4, step 4 is relying on the grid last. So I talked earlier about the community choice aggregates. You can see here, most of them are set up in this kind of 3-tier format. That tier 1, if you read closely on that 3rd bullet point, it's actually a 1.5% discount compared to Pacific Gas and Electric. So if you sign up for that CCA, you're saving money. If you move into the middle column, you can go to 100% carbon-free electricity at no cost upgrade. So that's a very attractive. And our client said, you know what, we want to go fully renewable. So we're willing to pay that 1 cent per kilowatt hour premium. And the only difference between carbon and renewables is hydro. So here again in the state of California, hydro is a 0 carbon source, but it is not a renewable source as we continue to be in a severe drought. So moving on to some of the results, and you can see they're still collecting. We've had some challenges with the utility of getting that solar and storage online. We're still working that through, so that is a challenge, which I'll get to when you see the performance numbers. But this is a typical cell therapy where you have warehousing, you have office space. Here's our QC, so a lot of benchtop equipment. We also have a pretty healthy amount of clean room manufacturing. So again, MAB facilities, monoclonal antibody, where you might scale up. Cell therapy, you're scaling out. So that's why you're seeing the future expansion on the left-hand side with our phase 1 build on the right-hand side. So when people say, yeah, that's great, 0 carbon, that might work for residential or light commercial. Well, yes, it can actually work for GMP manufacturing as well. As far as performance data, if you have not been on that I2SL site, there's a laboratory benchmarking tool that I highly encourage you to check out. There's about 1,000 entries. I'd love for that to be 10x, but if you can go on there and enter your own facilities, we can start to collect more data. So this is where Allogene shook out, about 123 kBTU per square foot. So you can see that it's in the top 10%. This is a golf scores, lower is better. So their energy use intensity is in the lowest 10%, which is really great, especially considering that they are GMP manufacturing. This data is about 5-6 months worth of data that does not include the solar that has come that is not yet online. So once that solar goes online, we anticipate that number will drop in about half, and we'd be in the top 3% of the entries on I2SL. So pretty happy with that. And then really my last slide here is the wrap up. I don't know if Maddie's on the line, but Maddie, our graphic designer, put this together. It actually got put up on the AT&T Park up in the San Francisco Giants Stadium for ISP Vendor Night. So that was really cool to see that up there. But Yeah, to rewind, if you remember, this client said that carbon, water, and resiliency was their most important items. So we provided a zero carbon design through all electric and consuming all electric from the grid, or clean electricity from the grid. We made it more resilient by producing half of our power on site and then storing that with a battery energy storage system. And then from a water standpoint, I didn't mention this, but when we went with the air, water heat pumps, we don't have a cooling tower tied to that. So we were able to save 12 million gallons of water annually, not to mention the chemical treatment and the just cost of maintenance associated with running cooling towers. We did use LEED as that platform of measuring success, and we're anticipating LEED Gold. That will be finalized once we get the solar online and we can commission it properly. And the last thing I'll mention is that we actually did this for no upfront capital. So the $5 million worth of solar and storage was all financed through a power purchase agreement. So the power purchase agreement, the financier was able to front load that $5 million worth of capital expense and then sell the power to Allogene at a rate that was lower than PG&E, but a rate that was higher than they were able to produce it. So it was really it's called a shared savings, and it was a win-win for both people except for the utility. So that was a really attractive, allowed Allogene to keep their money in the science and let somebody else, take care of the energy component. So with that, we have 10 minutes remaining, which looks like pretty good timing. I do see that there's a handful of questions, so let me just kind of pop up here. Don't know how applicable microwave, radio frequency, and ohmic heater are in pharma, but F&B, they seem to be large resurgent temperatures. I will have to reach out to you separately. Those are topics that I am not aware about. So Pablo, I will reach out to you and understand that. Why don't we see geothermal used on the industrial side? So geothermal does have two meanings. One is from a heat source heat sink, using the ground as that medium, or geothermal where you're tapping like a Yellowstone geyser. So I think we're talking about the heat source heat sink, which we are seeing customers want to explore more and more. I haven't seen anything happen at CRB other than that Kansas City facility that we did, 10 plus years ago, that uses the lake as that geothermal. But we're seeing it, at least talking about it more and more. I find that some of the gas measurement charts have been deemed to be realistic or declared some scientists correct. On the other hand, deemed blatantly misleading by other scientists, measured, determined most accurate as part of the million ppm, how many ppm or carbon is actually in the atmosphere. I might have to read that once some more time to fully grasp that, Lucian. I'm going to pause there.
Simply put, if you have 1 million parts, how many parts per million is carbon dioxide currently?
So I just put a link. I was looking at that question. I just put a link in the chat. That's one of the NASA measurements that's kept up to date regularly, and also a link to the UN report that takes a look at kind of where things are now and some of the projections. That's similar to what Jeff has, but the links to 2021 that came out earlier this year. So those could be helpful sources. But I think there are a number of different sources that show the ongoing measurement for the carbon ppm.
Where's the BES located? Data center rooms. So our energy storage system, it's located outdoors. It's just out in the open. And then there's a follow-on question of how many hours is the BES allow? So really, it's a 1 megawatt hour with 1 megawatt of solar. So it's 1 hour of storage at maximum generation. And then I think we have enough inverter to do that. It's either over 2 or 4 hours of discharge. I will say that our battery is quote undersized, and part of the reason for that is because as a financier, you can oversize a battery, but you can't really undersize one. And what I mean by that is that if you have a small amount of battery, then you're going to always get 100% utilization. If you have a huge battery, you may not ever fully charge it, and so then you can't fully discharge it. So from from an investor standpoint, they want 100% utilization. So that's why they erred on the downside. We do have space for a second one. And just as a rule of thumb, generally 1-to-1 is very safe. Megawatt hour to megawatt is very safe. 2 is probably good, and 4-to-1 is relatively aggressive. Relatively, unless you're, Facebook, Amazon, Netflix, one of those FANG companies. Jeff, our website blogging does not do enough bragging of the cool things we're doing outside of business. I agree, Jason. Let's make that change happen and get some of these stories. Allogene did just kind of go public recently. Even though this was a 2018 design, it takes a long time to get where we are. So we do have a full write-up, and we just need the green light from them to press send, and it will be on our website shortly. Have you seen any metrics that track additional maintenance that these lower emission buildings require? This may be useful to push back on the belief that the newer technology requires more maintenance than traditional approach. So I think that's still kind of, that's a tough one to answer. As far as metrics, it's not that heat pumps are new, it's just that the applications are changing, right? So we have heat pumps, in our car, in our house, but doing it on a central plant, ideally, I mean, it should be lower, right? There's no water treatment, it's all closed loop. There are a lot of compressors, and so it's not a matter of if, but when those compressors will fail. There are more fans. So each 60-ton module has 2 compressors and 4 fans. So when you multiply that out by a 600-ton plant, I mean, you're starting to get quite a few numbers. So I like to think that there's kind of some inherent resiliency, but the reliability of each one of those components certainly starts to become a little bit of a burden, and you're going to have replacements over time. Got a couple of minutes left. If anybody, I do see some hands up. I can't see who it is, but if you want to take yourself off of mute, feel free to ask another question.
Yeah, hey Jeff, it's Carlos in LA office. So I guess I got a more inward-facing question as to as CRB, what are our sustainability commitments? I think a lot of the sustainability things that we talked about in office are primarily client-driven, right, based on the client goals. And so as a firm, like, do we have a commitment to build sustainable projects? From the architecture side, right, a lot of firms out there, they're saying, like, all our office projects, regardless of the client, are going to be built, I don't know, LEED standard, right? They're going to be, some firms do that, other firms have different commitments. And then the AIA itself has the 2030 commitment, which forces the architecture firms themselves to make an actual commitment to meeting certain climate goals, which means that you have to be certified and track a lot of your projects through that system. So from a firm-wide standard, from a culture firm-wide standard, what's our individual commitment in the firm? Yeah,
no, that's a great question, and I think Adam, who was not able to join us, he is our senior manager of sustainability and helping kind of navigate CRB.
I'm on, Jeff.
Oh, hey Adam, do you want to respond to that?
I've been listening. So currently we are in the process of hiring a third-party consultant to help us set our greenhouse gas baselines as a company. And then from there, what we'll be likely moving into is setting science-based targets according to the Science-Based Target Initiative and getting those validated. And along with that lift, we will set our project-based goals. So we've already been talking with Mike Morris and TAG and the TAG leadership teams and our new director of specifications about incorporating sustainability into our specs on projects as just a standard of the buildings that we design. So it is a conversation that's happening. It will be tied to the Science-Based Target Initiative as we continue to go through that process. Did that answer your question, Carlos?
Yeah, thanks.
See a couple other things in the chat window as far as some links. So feel free to to check those out. You mentioned top sustainability goals, carbon and water resilience. What was the most common concern hurdle with clients bring up along the process? Gosh, that's a good question. I mean, I think there's a few. I could say that it's very easy for some of these corporate directives to say we're going to be zero carbon, and then the sites are left kind of holding the bag of like, well, how do we do that? And so what CRB has found is that that's where a lot of our value is that we can help guide them to how they can accomplish some of those goals. I will say there's a lot of, I don't know if uncomfortable conversations is the right way to say that, but, doing things differently. If we're doing things the same way, I think even Pfizer has that Einstein quote, if you're doing the same thing, expecting different results, that's the definition of insanity. So we do need to challenge each other to do things differently if we're going to have different outcomes. If we're going to hit water neutrality or carbon neutrality, we certainly need to push the envelope. So air change rate reductions, ambient WFI, and electrified heating systems, those are probably the three big ticket items that seem to come to mind that are constant big hitters, but with a lot of stakeholders that have difference of opinions. Can you comment on the increasing demand of the mining industry for metals? Ooh, yeah, I know where you're going with that one. Can you comment on the recycling possibilities of solar panels versus throwing them in landfills? So a lot of this, there's a just because an EV, doesn't have emissions doesn't mean that it didn't have an environmental impact. I think a lot of us, we treat it as, well, it's not in my backyard, so kind of not my problem. But yeah, no, those precious metals they came from somewhere. I think most things I read that the overall net benefit is positive when you look at the life cycle. But I'm sure that there's just so many factors that I certainly could not respond, firsthand to that. I can only respond, anecdotally from my reading. Great. Looks like some people are needing to drop off. Well, I will, looks like there's a minute here, so I'll close it with the fact that, so we are going to send out both of those documents, both the how-to so that you can review that on your own. We're going to give you this template so that you can leverage this. If you ever want to reach out, maybe, have someone else do a charrette and you shadow or vice versa, welcome to do any of the above. But I'm just incredibly excited that this relatively easy exercise can really wind up into these amazing stories. So I think Ryan said it on the town hall last week that, Allogene might be our first, but it most definitely won't be our last. And I'm excited for what we come up with, collectively as a group and keep pushing the envelope and, keeping that preeminent status. So appreciate everyone joining us. And if you do have any follow-up questions, by all means, reach out afterwards and I'll make sure to get those answered. Appreciate everyone's time today.
Thank you so much, Jeff, and thank you so much for everyone that was able to join. We had a great turnout and excited to be able to share more knowledge. Please join the community of practice if you're interested in more conversations like these, and we hope to have more excellent trainings in the future as well. Thanks again, Jeff. This was fantastic.
Will you post this video to the sustainability SharePoint?
Absolutely. This video will be shared on the Sustainability SharePoint, and we'll make sure that everyone has access. We'll be able to put that link in the community of practice as well. Good call, Adam.